Hi, in today's video I would like to introduce you a very nice International Mathematical Olympiad edition 2020 question number 2. Here is the setup. We have all positive real numbers, A superior equal to B, B superior equal to C, C superior equal to D, and D strictly superior than 0. Okay, so here is the condition. We have this sum of these numbers A plus B plus C plus D equal to 1. The question: prove this statement: A plus 2 times B plus 3 times C plus 4 times D. The whole thing is multiplied by this product: A to the A, B to the B, C to the C, D to the D is strictly inferior than 1. Okay, so the easiest way to prove this one, we are going to apply the important and useful formula, which is called arithmetic mean geometry mean value theorem. Here is the statement. We have the sum of these numbers, the sum of as I goes from 1 to the n, lambda I is multiplied by e to the I sub I, superior equal to this product as I goes from 1 to the n, a to the sub I to the lambda I. Okay, I'm not going to prove this one because I already proved this one, so the proof is available in my old videos. At the end of this video I will add the link to the comment section where you can see all the details. Okay, now let's get started with this one now by applying this theorem. So I have this formula: lambda 1 is multiplied by a sub 1 is multiplied by e2 to the lambda 2 and all the way down until you get the last term. So we have only 4 terms here. I'm going to set lambda 1 equal to a1 equal to a, okay, and lambda 2 equal to a2 and equal to b, and lambda 3 equal to a3 equal to c, lambda 4 equal to a4 equal to d. Okay, so I'm going to apply this theorem on these numbers a, b, c, d. So I will have a is multiplied by a plus b is multiplied by b plus c is multiplied by c plus d is multiplied by d. The whole thing is superior equal to a to the a is multiplied by b to the b is multiplied by c to the c is multiplied by d to the d. Okay, this one is giving us a square plus b square plus c square plus d square is superior equal to this product: a to the a is multiplied by b to the b is multiplied by c to the c is multiplied by d to the d. Okay, by flipping this inequality, I'm moving over this product to the left hand side and this sum to the right hand side of this inequality. Okay, I will get a to the a is multiplied by b to the b is multiplied by c to the c is multiplied by d to the d is inferior or equal to this sum: a square plus b square plus c square plus d square. Okay, I'm going to multiply both sides by this term: a plus 2b plus 3c plus 4d. I will get a plus 2b plus 3c plus 4d is multiplied by this product: a to the a, b to the b, c to the c, d to the d is inferior or equal to this one: a square plus b square plus c square plus d square is multiplied by the same term: a square a plus 2b plus 3c plus 4d. Okay, so this term, I'm going to prove this term is strictly inferior than a plus b plus c plus d cubed equal to 1. Okay, if I will able to prove this product, which is strictly inferior than this term, which is a plus b plus c plus d cubed equal to 1, that's mean I will done with this problem. Okay, because this term is arithmetically is inferior or equal to this term, that's mean if you prove this one is strictly inferior than this one, that's mean this the whole thing is strictly inferior than 1. Okay, that's what I'm going to do now. I'm going to compare these terms. I'm going to compare these two expressions, which this one and this one. Okay, I will start with this one first. As I said before, I'm going to prove this term is strictly inferior than this term by comparing this product and this number here. Okay, so I have a square plus b square plus c square plus d square is multiplied by this sum, which is a plus 2b plus 3c plus 4d. Okay, by distributing this, by the factoring this out, I will get a cubed plus 2 times a square b plus 3 times c a square plus 4 times d a square. I have done with this first term. I'm going to start with the second term. Second term, I will have a is multiplied by b square plus 2b cubed plus 3 times c b square plus 4 times d b square. Okay, the second term I will finish with the second term. I will start with third term now. So I will have plus ac square plus 2 times bc square plus 3 times c cubed plus 4dc square. I finish with the third term. I will start with the fourth term. Fourth term, I will have a is multiplied by d square plus 2 times b d square plus 3 times c d square plus 4 d cubed. Okay, I get all the terms distributed. Okay, I'm going to take a square out of this one as a common factor. I will take also b square out of this one as a common factor. I will take also c square as a common factor. I will take d square as a common factor as well. Okay, I will start with a square. This one is giving me a square is multiplied by a, the first term. So I'm collecting all the terms which has a square and put it as a common factor. Okay, so we'll get a square is multiplied by a plus the second term 2b, this one. For the third term, I will plus 3c. For the fourth term, I will get 4d. Okay, now we are looking for the b square. We have the b square, this one is multiplied by a is multiplied by 2b, and the third term, which is this one, is multiplied by 3c, and finally the 4d. Okay, plus c square is multiplied by a plus 2b plus 3c plus 4d. Finally, I will multiply d square. Finally, I'm taking d square as a common factor. Square is multiplied by a plus 2b plus 3c plus 4d. Okay, I'm going to work on the other side, which is this one. So I have a plus b plus c plus d cubed. If you distribute this one, is given as square is multiplied by this term a plus 3b plus 3c plus 3d. Okay, then the second term will plus the second term. I will get b square is multiplied by b plus 3a plus 3c plus 3d. Okay, for the third term, I will get c square is multiplied by c is multiplied by 3 times a plus 3 times b plus 3 times d. Okay, for the last term, d square is multiplied by d plus 3 times a plus 3 times b plus 3 times c. Okay, I have a kind of patterns here. It's easy to compare. So plus this term 6abc plus 6 times abd plus 6 times acd plus 6 times bcd. Okay, now I have this. I'm going to compare this term with this term and this term with this term. Okay, and this term with this term. Finally, this term with this term. Okay, plus the last term. If you take a look, we have A superior equal to B, superior equal to C, strictly superior than D. Okay, E is the biggest one, so A is bigger than B, B is bigger than C, C is bigger than D. So that means all these terms, A is the biggest one, D is a smaller one in these terms. If you try to compare term by term, and you look at this term as the first term, you will see all the terms are the same. We have A square, AA, we have 3C, 3C. The only difference is 2B, we have 2B here and 3B here, and we have 4D in the first term, 3D as a last term in the second term. Okay, so when you see 2B when you see 2B here and 3B here, that means this term is strictly inferior than this term, because B is bigger term than D. D is a smaller term. So even though 4D is a superior than 3D, but it's very small number because it's a smallest number in these terms. Okay. Finally, this term is smaller than this term. Okay. Let's move on to the second term. For the second term, which is in blue, if you take a look at second term, which is B squared is multiplied by this one, by comparing it with this one, you will find this one is smaller than this one, because if you take a look at here, we have A is a bigger than all other terms. Okay, and when you multiply 3 by the biggest number, is giving you the biggest number here. Even though we have 2B here, it's not going to affect our inequality. Okay, because 3A is taking the power as a big number in these terms, so this term is smaller than this term. Okay, let's move on to the third term. If you take a look at the third term, all the numbers are almost the same, except 3A and 3B are the most powerful numbers as a big numbers in these terms. By multiplying 3 times A plus B is giving you the big, that means there is a huge difference between this one and this one. Okay, don't look at the 4D. 4D is a very small number because all the numbers are bigger than D. Okay, so this means this term is strictly inferior than this term. Okay, let's move on to the last one. The last one, this is easier to compare, because since we have 3A, we only have 1A here, we have 3B, we have only 2B here, we have 3C, we have the 3C that are the same, but we have 4D. The 4D is nothing, because the 4D is very small number, because it's a smallest number in these 4 numbers. Okay, that means this term is strictly inferior than this term. Now we have proven our proof. Thus A plus 2B plus 3C plus 4D is multiplied by this product. A to the A is multiplied B to the B, C to the C, D to the D is strictly inferior than 1. Okay, so I have done with this problem. Again, if you are interested to watch this proof, I'm going to add the link to the comment section below. Just consider subscribe. If you have any question or suggestion, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.